Hello, everybody. I have really nothing to declare. I have several consulting relationships, but some of them wish to remain undisclosed. But I can say that everything I'm presenting here today is my own view, and when I'm using materials from a company or an organization, it's either publicly available information or I've requested their permission to use it. I do want to thank ILSI, though, for supporting me to be here and participate and give this presentation today. So I'll be focusing on sugar reduction and salt reduction because of their importance, because of our time limitations, and because that's where a body of my experience lies. I came to realize this morning that I've spent nearly half of my 30-year career in the food industry on these challenges. So we'll do this in three parts. First, industry progress. Second, industry challenges. And third, industry approaches. So for industry progress, what has the industry achieved? And for that, it depends a little on who you're asking and how they've measured it. So I want to share a few different report cards to give you a flavor for that. Here are two from two different food companies that take a similar but slightly different voluntary approaches. They're both from 3-year efforts. So in 2012, Kraft Foods reported on their goal to reduce, on average, sodium by 10% across their entire North American portfolio. And many staple products achieved that goal. Some, a handful, exceeded it by, even in one case, the easiest case I've ever encountered, up to 40% reduction. And this effort involved thousands of SKUs, 25, almost 24 different product categories, and hundreds of products. On the opposite side, you have General Mills, who blogged in 2015 on a similar effort, but their goal was to reduce by 20% across 10 key product categories, and they succeeded in meeting that goal in 7 of the categories, and they came close for 3 others. Really, that was an effort that involved, I can't remember, but over 300 products initiatives in their case. So here's another report card. This one is from New York City's NSRI, or National Salt Reduction Initiative. It covers approximately the same time frame, and they published the progress in American Journal of Public Health. Their goal was to reduce sodium by 25% over a 5-year period, and this included also restaurant foods, not just retail sales. They found at the end of the period that almost about a quarter of the products that they looked at met the goal of these category-specific targets, and that the mean sodium density declined in almost half of the products they studied. And it was a significant decline, but overall you see modest, just under 7%. And the third and final report card is from a USDA study from late last year. This is based on retail data across 17 different product categories, and I believe it was between 2008 and 2012 that they did this look. And so they found that there were gradual sodium reductions in 4 out of the 5 categories studied. Very few products had any kind of sodium or reduction claim, more on this later, and that despite the availability of processed foods with lower sodium, most households still actually bought products that had what they described as excessive sodium density. So I think it's fair to say, looking at these 3 or 4 different report cards, that the progress is real, but modest, and challenging and slow. So for part 2, industry challenges, we'll look at the multifunctionality of sugar and salt, some differences in our knowledge base around sweet versus salty taste, and some business considerations. So when we talk about reducing sodium foods, it's not just sodium chloride or table salt. It's a whole bunch of different ingredients you see listed there in the center that are sodium containing. And it's also not just salt taste, as others have alluded to. Sodium-based ingredients, including salt, but not only, play a number of other roles in food that you see here. So on the taste side, we've already heard that sodium chloride has a unique salty taste. It's a good enhancer of savory flavors. And it's a very effective reducer of off-taste, notably bitterness. For the taste and texture side, this turns out to involve a lot of the sodium phosphates, particularly. Those are emulsifiers that are important in water holding and creating firmness and making juiciness in processed meats and cheeses, as a good example. Sodium bicarbonate, a leavener, is quite important for rising of bread dough, and it also strengthens the protein, the gluten matrix in the bread. And last but certainly not least, sodium chloride itself, in addition to sodium lactate, benzoate, propionate, and others, are important for preservation of foods, basically by controlling the growth of spoilage and pathogenic microorganisms. So this multifunctionality complicates our attempts to reduce sodium chloride and other sodium-based ingredients in food. Similarly, for sugar, there are many other roles besides just the nutrient and the specific taste role. And I just want to highlight two of those, because the bulking or body aspect, in my experience, creates particular challenges with sugar reduction in baked goods and in beverages. You've also got to address, preservation in jams if you remove sugar, and the brown color of many cooked foods that has, which has involvement from sucrose as a Maillard browning color producer. So let's just review quickly, since we've heard some of this before, sort of the evolution of sweetness technology. So it started, I forget which one of these was the pointer. Is it the red one? Okay, I don't want to press the wrong one and start over or something. There we go. Okay, so it all started over 100 years ago with the accidental discovery of saccharin. And since then, I guess it would be an intervening 130 or so years, many other synthetic non-calorie sweeteners were discovered, and you'll recognize some of those as being used today in food. Those are considered mature technologies today by the industry, meaning they're completely monetized. You're familiar with them as ingredients. You see them in products. And then in about 1995 or so, until still now, there was a shift from sweeteners, so replacers, to enhancers that are combined with sugar. And Chris just talked about these, so you probably remember the PAMs, the positive allosteric modifiers, and FMPs, or flavors with modifying properties. So these are things that, in two very different ways, enhance the sweetness of the main sweetener. And then from about 2000 until still now, industry anyway, has been very, very heavily focused on natural non-caloric sweeteners and sweetness modifiers. So you see examples of a lot of these listed here. What about our receptor knowledge? Gary and others have alluded to this already. There's a very solid and deep knowledge of the sweet taste receptor, not only the receptor, but also where many of these sweeteners bind on that receptor, which is actually amazing, and I think due to the very long history of our knowledge here, because there's a lot of structural diversity in these sweeteners. So what about a comparison for salty taste? Well, it's hindered by about 100-year later start in the research. So back around the 1980s, it's kind of when I was starting in the food industry, were the first looks really at salty replacers and substitutes. People started looking at alternative salts to sodium chloride. This is when the bitterness issue first surfaced, it's reported. It's also when, well, even back then, Rick Mattis and others postulated that it was going to be pretty challenging to find a very appealing and good, effective salt substitute, which I think has borne out. Then there was an evolution to salt taste enhancers, and there are many, many of these, ranging from monosodium glutamate and its replacers to acidulants, yeast extracts, a whole bunch of different flavor house solutions, and some other, trehalose and allopuridine that are in the literature or are patented. In my personal experience, these, I don't mean to say they're unuseful, but they're not big solves. They help a little bit, but they don't really help a lot. They're important and you need them, but they don't solve everything. And then from about 2005 on, you start to see people really working hard to find modulators for bitterness. This is because of the potassium chloride substitution. And there are a number of different ones here. People were pushing away from broad bitter blockers toward more targeted bitter blockers or bitter modulators, and trying to find proprietary ones that they could use for competitive advantage. And in terms of human salt taste detection, as Gary mentioned, the putative main mechanism is an ENaC, or epithelial sodium channel, which responds almost exclusively to sodium. The influence of the chloride ion is unclear, but it's also clear that there's some sort of additional mechanism which detects saltiness of potassium chloride, but the receptor and the mechanism are unknown. So I'll have a little more on that later. Now, since this is an industry perspective, I want to just briefly mention business considerations. And so it's important to remember that business is a for-profit enterprise. So anything that we in industry do with the product has to be profitable. And there are a lot of different consumer expectations and manufacturing and other costs related to making products that come into play when we try to figure out how to make a successful product. What does this mean for nutritional improvements in products? I think it means that a nutritional improvement can only be successful if it's successful with consumers. So there are all those different consumer expectations. I've just distilled a few of what I think are some of the most relevant ones to what we're talking about today. I'm not mentioning safety, which is obviously probably the most important one because that's a non-negotiable given. So beyond that, you have taste, which is a key driver. And what we've found, at least in my experience, is that there's no need for an exact taste match when you're reducing sodium or sugar, but you do need to achieve near parity preference or near parity liking. Otherwise, you don't succeed. And in terms of these aversive or bitter tastes from some of the high-intensity sweeteners and from potassium salts, only a relatively small portion of the population, maybe on the order of 20-ish%, detects those. But from a consumer complaints perspective, that's a huge amount. So those problems have to be addressed to make successful products. After taste, cost is the next biggest obstacle. And our industry cost for salt today for sodium chloride is about 10 cents a pound. And just for example, potassium chloride is 8.5 times that cost. And that's without adding any bitter blockers or anything else. And similarly for sugar, as Chris mentioned. And you've got to remember that food is a commodity, low margin business. So a lot of this cost has to get passed on to consumers. Which brings me to the last point, which is consumer expectations are kind of a wild card. So for a while it was they wanted improved nutrition. Then it went to, we also want natural. No, we also want clean label. Today it's getting about sustainability and social and environmental responsibility. And I don't know what will be next. And these changes often happen very rapidly. So you're kind of catching up with them from an industry point of view. So it's very challenging. This is just a bit more on commercial viability metrics, and I just wanted to make the point really that when we talk about taste, it breaks down into at least 4 different aspects, and I want to highlight 2 of them, flavor profile and temporal profile, and just use sweetness as an example. So you can see from the chart on your left that, maybe you can't read this from back there, but the blue bar is sweetness, and the red and yellow bars are bitterness or licorice taste. So in every one of these sweeteners that you see here, except for sucrose, which is on the left, you get some bitterness and some licorice involvement. And it's low level, but it's not unimportant, so you have to work with that. And in terms of temporal profile, if you look at the graph on your right, the sort of normal green is the sucrose, this one. And you can see if you look at the purple, which is thaumatin, it drops way too quickly compared to sucrose for maximum sweetness. And if you look at the bright green line, this one on the outside here, sorry, that was the thaumatin. This other one was cyclamate. The purple was cyclamate, but the point is the same. The thaumatin lasts way too long in sweetness or lingers. So all these kinds of things you have to deal with. All that said, here's just, I think, many of the top natural, non-caloric sweeteners that are on the market or under development today. And there are a number of good choices. Many of them are relatively clean in terms of taste, but there's a cost trade-off for those. Those are the more expensive ones. And you can see that different companies are taking different solutions. And there's a lot more to say about industry approaches here today, but you can talk to me after if you want to know about that. There's a lot of blending going on and new things. Lots of options in the sweetener area that are pretty good. And we can't forget about the bulking part. So this slide is here to remind me and you of that. And so these are just some of the things you can use to solve that problem. And I would say the best ones right now today are erythritol and allulose because they balance commercial readiness with cost, and you can do a non-artificial sweetener label, and they're non-caloric. Okay, that brings us to part 3, industry approaches, and for this I'm going to focus just as a kind of a deep dive on sodium, and we'll talk about some marketing aspects, some technical approaches, and then pushing the boundaries. This is just to remind you that although we're going to focus only on taste, from an industry standpoint, we also still have to be thinking about the textural and preservation functionalities of the salty ingredients. And so we're working on, an ingredient and processing solutions for those other functionalities. Also with taste, which is the fleshy colored ovals, it tends to go in stages. So I think, most of the low fruit has already been picked, and we're kind of in this intermediate solution kind of phase. And for the next stage, to get better results, we need breakthrough solutions. Okay, so this is about the marketing part, and generally gradual or stealth reductions are the rule because drastic reductions lead to noticeable taste changes. People don't like it, they stop buying the product or they switch to a competitor's product. Not only that, but they don't even want to buy any sodium-reduced product anymore, and so there's a whole poisoning the well kind of concern, which actually is confirmed by this publication, which I've noted here, and this particularly deals with front-of-pack sodium reduction labeling. And this study showed that when people see a lower sodium label on the front of the pack, it lowers immediately already their expectation of how this product is going to taste. They think it's not going to taste good and they don't want to try it. It also lowers their actual liking and their actual perceived saltiness of the product once they taste it. Even if you put that label on a full sodium product that's not reduced, the label has that effect. It also actually, as this study found, causes people to add more salt at home. So a viable and better solution is overall health or wellness labeling on the front of the pack that doesn't specifically call out sodium reduction, as you see over here on the right. And so, I like to call this a taste then tell strategy, where ideally you would let people actually taste the product first and then tell them that it's healthier and sodium reduced. In terms of standard industry approaches, different people have talked about different parts of this, so this just pulls it together. I'll say that generally what you begin with is an analysis of which sodium-based ingredients in the food are contributing sodium, and looking at what their functionality is in that specific product. And then you start trying to figure out reformulation. And it really is category by category, even sometimes product by product. There is no magic bullet. So the solution that works one place doesn't work in another. Simple reduction or removal is very rare. I've only saw that work in one single product in my experience. Generally, you've got to use a lot of these other types of solutions that I and others have already mentioned to try to readjust the flavor profile. And so you try that first, and then if you have to do something else, which is usually, you go for partial substitution of the sodium chloride or the sodium-based ingredients with potassium chloride or potassium-based ingredients. Potassium chloride is the choice because it has similar ionic strength to sodium chloride, so you keep a lot of the other functionalities. But it is less and differently salty than potassium chloride, and it does have this aversive or bitter taste problem, and even for small portions of the population can be a medical issue if they have to watch potassium. So it's not perfect, and you reach a plateau in terms of how much reduction you can get. So that's when you start going for bitter blockers, and with those you can go further, but you then reach another plateau, which is kind of where we're at today, I would say, in general. So how can we push beyond those boundaries? Well, we need better salty and better bitter modulating or blocking ingredients. Also, knowledge building, particularly around the reception mechanism of salty for both, thank you, sodium chloride and potassium chloride, and the bitterness of KCl would be helpful. And I wonder, as someone else alluded to, I think maybe Gary Beecham, whether some more in-depth knowledge around this gradual reduction strategy bit could help, because we don't have a modern, carefully controlled, across the whole diet sodium reduction study to see about this matter of how people gradually adjust and how long does that take, how long does it last forever, what about, there's a million questions here that we can talk about in the panel discussion. And the last thing to push the boundaries is really both industry and consumers have to be open to embracing that means actually higher ingredient and regulatory costs and complexity. So salt is a pretty simple ingredient, and you've got to add more things and more expensive things to help that. So in terms of deeper knowledge around the receptor, Monell has been tackling this question, and their credibility earned them a $1 million gift some years ago to study this. As you can see, it's not an easy and a quick question. It's been going on for a while, and I just want to share with you a few of what I can find from publicly available information, a few of the most recent findings around the human salt detector. All of this is from Monell, except for one point, which was from a meeting 2 months ago from a different lab. So it's clear that there's this at least second receptor system that responds to both sodium and non-sodium salts, including KCl. The chloride, it seems to be sensitive to the size of the chloride molecule. So if there's a small, or not just the chloride molecule, the cation. And so if there's a smaller cation, you get more perceived saltiness. The chloride role is unclear, but there's some recent data from Steve Roper and the Roper and Chaudhary labs at University of Miami, just from 2 months ago, that suggests that maybe chloride transduction underlies this whole component. It's all still unknown. We're finding out more. And then back at Monell, recently human salt taste sensing cells have been isolated and identified, and so hopefully analysis of the genes and proteins expressed in those cells should help move us towards elucidating this receptor. Now, another tool that Chris alluded to is receptor cell-based taste modulator discovery. And for any of you who might not be familiar with that, it's adapted from the pharmaceutical industry, where automation or high throughput screening is used to screen hundreds or thousands, rapidly screen hundreds or thousands of potential drugs, or in our case, taste modulating molecules, and narrow that down. What enabled us to use this for finding taste modulators was really the whole molecular era when we started discovering the taste receptors. So Sonomics was, I think, the first to apply this approach for sweetness. Then the bitter receptors were discovered, and there's been some efforts, including one that I was involved in at Kraft, to try to find bitter modulators using this approach. And you know, wouldn't it be nice if we knew the whole salt taste receptor, because we could go look for salt taste modulators that way. But brain and analyticon discovery, even using incomplete salt taste receptor knowledge, have made some progress using this approach, which resulted in a patent here for their food industry partner. And you know, I don't know whether they've commercialized this or not. I'm not privy to that information. But the one thing I want to say about this approach is the upfront part of it is very fast, the automated part here. But I'd be remiss if I didn't mention that the time to actually, you know, having a commercialized product containing one of these things has got to be, you know, on the order of 5 to 7 or 10 years, because we still rely mostly on human taste panels to narrow down the many hits that come out of a screening like this, and also because you know, sometimes you have safety testing and regulatory approval because you're discovering a novel molecule. I want to leave you with some hot off the press data from the lab of Thomas Hoffmann and others at the Technical University of Munich. And their findings suggest that actually our saliva may have a role in how sensitive we are to salt taste with sodium. So obviously this opens some new avenues for salt taste enhancing strategies. With that, I want to thank you for your attention and your interest, and hope that you have these key takeaways from my part anyway, which are that sodium and sugar reduction are complicated by their multiple roles in food. The progress in industry has been significant, but it's very challenging, it's arduous, it's modest, there's lots of room for more. We have much more history, options, and knowledge, I think, for sweet than for salty. And if we're going to succeed, the nutrition improvements have to be successful with consumers. And key things there are taste, cost, and evolving consumer expectations. The stealth, gradual, and taste rather than tell strategies working better. KCl is still the ingredient of choice today, but it's got some limitations, and it would be great if we could push the boundaries on that by some more knowledge building, which would help us discover new ingredients and other tools and approaches. Thank you very much.
We have time for one question or a fifth. I guess we could start. Oh, there we go. Sorry.
Just one question. Jane, do you have any experience with how oral microbiome, whether it has any impact on taste, based on your sensory work in the past?
I have no experience based on that, but I know of some work in 2 other industries that I haven't worked with going on in that particular area, and I think it's a very interesting and important question.
I guess we could take the question.
Thank you. My name's Christine Stewart from UC Davis, and I just had a question out of curiosity. You've talked mostly about post-harvest approaches to change salt or sugar, and I'm wondering if there's any efforts to work with producers, such as like with plant breeders, to try to alter the flavor profile of broccoli, for example, to make it less bitter, or to make the fruits and vegetables more flavorful from the point of harvest.
The answer is yes, and I'm not at liberty to divulge who and exactly what, but there is industry work specifically around trying to to identify some of the bitter principles, specifically in a few target vegetables, one specifically broccoli, and to try to figure out whether that can be, instead of just masking it, whether it can be reduced, as it grows. I thought you were going to ask me about sugar, so there certainly are efforts there to make, lower sugar varieties of certain crops. But yeah, I don't know how much work is in that area, though. Actually, it'd be interesting to know.
Right, so in order to allow us to catch up with our timing, we'll just take a 15-minute break and return at 11:15 for Dr. Zellner and a new approach to taste. Thank you very much.